Hey everyone, it's Matt with Spiceworks. Thanks for joining us on another Spiceworks Partner webinar, How to Reduce Disaster Recovery Expenses Up to 50%, brought to you by StarWind. First off, I'd like to remind everyone of a few things. There's a Q&A box on your screen to the left. We encourage you to submit your questions at any time during the presentation. We will get to those questions at the end via a verbal Q&A. But if your question isn't addressed live, StarWind will be able to follow up with you. Another thing to remember is that we are recording this webinar, so if you have to step out for a bit, it's no big deal. You'll receive a link via email to view this recording in a few days. It will be an on-demand presentation, so you can check it out as many times as you'd like. Well, that's all I have, so now it's my pleasure to introduce today's presenter, Chris Evans, co-founder and independent consultant at Langton Blue Limited. And he's also a blogger and part-time analyst at Architecting IT. So I'm going to hand it off to Chris and let him dive right in. Chris?
Thanks, Matt. Good morning, good afternoon, everybody, and welcome to the presentation. And thanks very much, Matt, for just taking people through who I am. And there's a small summary there on the screen, as you can see, which just gives you some of the links to be able to contact me should you need to after this presentation. So let's start by talking about what this presentation is about and what we'll expect to learn. So first of all, we'll talk about the need for business continuity / DR. BCDR as it's called in the business, and we'll explain exactly what that means. We'll very briefly discuss why that's different from hardware resiliency. So we'll talk about the difference between those two concepts, just to make sure that they're clear and where we should and shouldn't be using them. We'll talk about different strategies from the application downwards, and how we should tie those to our business service level objectives. We'll then look at different solution types based on recovery at the array, the hypervisor, and the application. As we get further into the detail, we start looking at some of the differences between the technologies. So we'll talk about the differences between VM level and LUN level recovery solutions, and of course, some of the technical solutions from the vendors that are out there today in the hypervisor layer, and some of the open source platforms. And we'll talk about some of the third-party vendors that are also offering solutions out there into the marketplace. So across the board, we'll talk across quite a range of the different technologies, and we'll sum that up at the very end. So let's get into the first slide. Let's talk about BCDR and what it means and why we need it. So first of all, there are two terms here that we're talking about quite independently. There's business continuity and there's disaster recovery. And if we had to divide up what they mean specifically, business continuity is all about putting processes in place that allow the business to continue if some major disaster or some incident occurs. Now, we'll talk about what those incidents could be in a little while, but obviously there's a desire to keep the business running should something happen to the IT equipment or the people involved in actually delivering the business. The second point we should focus on is something called disaster recovery. And this is the actual process of, if an incident actually happens, how we recover. So the actual process of going in and maybe re-establishing systems, re-establishing processes so we can continue the business on. And what does that mean? Why is this relevant? Why would we even want to do this? Well, if we look back, say, 20 or 30 years ago, IT probably was involved in the business, but it probably wasn't the major component of the business. People could survive if the IT systems were down for a short time or if there was some sort of outage. Now, that's changing in a number of ways. So first of all, we're now seeing people who are building businesses that have entirely customer-facing websites. So they're building businesses that are wholly dependent on a website or some EDI process, perhaps, to allow them to gain their business. And without that, they don't get business. Internally, customers are using purchasing systems, ERP systems for managing things like manufacturing, the marketing side of things, and sales and payments and so on. And of course, even as something as simple as email and deploying virtual desktop infrastructure is becoming absolutely critical to delivering the business and making a business run today. And what that means is businesses can afford little or no downtime to their systems. They can't survive with outages. One last point we should just point out here, because obviously a lot of our discussion today will be very technical. and talk about technologies and obviously a lot of that things around hardware and software products. But in general, recovery is as much about the process and the people than it is about the systems. Yes, you need to get your systems back, but at the same time, if you don't know how to manage the people around that, then you've got a problem. So this conversation obviously is a lot about the technology, but in general, you should be looking at it from the wider perspective of how you do that, how you manage people and process. So let's move on and get into a little bit more detail. Here's some really interesting stats that show why this is so important for businesses today. So I'll read through them just very, very quickly. 30% of all businesses that have a major fire go out of business within a year, and 70 fail within 5 years. And that's from the UK, that particular statistic, which is an incredible number. At a lower level, 31% of PCs have lost all their files due to an event out of their control. So without backup, the PC users have a problem with the technology. Quite worryingly, 34% of companies never test their tape backups. However, the ones that do, 77% of them found problems with the backup restore failures. So clearly, just assuming you've taken a backup and never testing it is a bit of an issue. 60% of companies that lose their data will shut down within 6 months of that disaster. Data for a company is becoming the lifeblood of that organization. Whether that's data in your email system, whether it's Salesforce, whether it's an application, the actual data itself is absolutely critical. And as we can see here, disasters happen. 140,000 hard drive crashes in 1 year, according to Mozy. If companies can't get their systems back, if they struggle to get it back, within 10 days, if they don't get it back, the chances are they won't survive. So it's pretty clear that technology has become a major part for many companies. And just before we move on to the major part of the presentation, I'll just take you through one particular example that happened in the UK. So a few years ago, now I think it was 2005, we had an incident in an area called Buncefield in the UK, and this picture is actually from that incident. At the time, there was a number of offices that were situated around a very large depot that was used for storing petrol and oil. And unfortunately, there was a leak of vapor. The petrol was ignited, and the tanks blew up, and it caused an explosion that registered something like 2.4 on the Richter scale, and was felt 300 miles away. A number of companies actually had their entire data centers and head office wiped out completely, and had to rebuild and had to implement process from that point. So a disaster can be as big as you can see here, loss of damage to computer systems has happened in that instance, and that could be fire, it could be a power failure, it could be flood, it could be earthquake, or in this instance, it could be an enormous explosion. It isn't just tied to computer systems, of course. It could be the inability to access other features around that. So it could be your offices where people work, it could be the head office, and that could be for the same sorts of reasons, or it could be flood, hazard, which could include things like chemical, radiation, or gases. Now, those are probably the worst case scenarios, and we can talk a lot about those, but in actual fact, there are many other things that go on. So we do see criminal and malicious damage from people. We do see disgruntled employees hacking systems and doing things they shouldn't do to them, leaving backdoors in there, deleting data and so on. And obviously we see lots of instances when hackers break into systems and they could try to maliciously destroy stuff. And finally, one thing we should consider as well is system or application failure. And that can be software bugs, failed upgrades, or something as simple as data corruption. The reason I mention these particular types of examples is that when you're designing how you should do your DR, it isn't just a case of thinking purely that you're recovering in order to bring back a system because you've lost a computer or something similar. Things could be more subtle, and it could be something as I said, more as subtle as an application failure or data loss, and you may want to roll back or you may have to roll back. So the way in which you implement the system actually could be more complex. So let's move on. So as you can see there, we've talked about why we would do why we would need disaster recovery and what the purpose of implementing it is. And we should be very specific about what it means and what other technology that we would normally put in the data center actually does for us. I would hope at least, everybody is aware of what hardware resiliency would mean. So hardware resiliency is where we say we're adding things like extra power supplies to a server, so if one fails, another one can take over. We may put in multiple network connections. We may use RAID storage, and so on. All of those things provide resiliency for that piece of hardware. What they don't do is cater for a disaster. So they give you a localized recovery if a component fails. And that's very different from implementing something that allows you to recover from the loss of all of that equipment. And you can't rely on one. You can't rely on hardware resiliency and think that it gives you some sort of BCDR type policy, because it doesn't. You have to think in a bigger way, and as I think I've just said on the screen there, you have to think about not only instating systems, but you have to think about the effect it has on staff, process, and everything else that goes with it. Of course, we should still use hardware resiliency. Let's not assume that that one doesn't need to be done. Of course it does, but it's not actually going to provide us recovery in the instance of a disaster. Okay, let's get some definitions out of the way, because this will help us understand what we mean when we talk about some of the features later on that technology provides. So there's two real measures that people use when they talk about implementing DR strategies, and that's recovery point objective and recovery time objective. So the recovery point objective describes at what point you're prepared to go back in the past to recover that data to. So I'll give you some examples here to try and explain what that means. So for instance, for the system that looks after your bank account, a recovery point objective would have to be 0. You don't want to lose any data. You want to literally go back to the point where the system failed or you had the disaster, and you want to keep on processing with no data loss whatsoever. Now, systems that are outside of something as complex or as important as that, for instance, a reporting system, you may have a recovery point objective that's 24 hours in the past. So you can work from yesterday's data. And the reason for that might be because you know you can regenerate today's data from somewhere else from the system. So there's no point spending lots of time and effort recovering a reporting system back to that point. Equivalently, things like development systems and so on may be more appropriate to put on a longer recovery point objective, because you can afford to have some loss of time there if developers can recreate their work. Then we have recovery time objective. Now this is a number that says how long do we want to wait before the systems are back up and running. Now in an ideal world, if money was no object, I'm sure we'd want our systems to be back up instantly. And we can achieve that with certain technologies, but of course there's a cost associated with that. And in many cases, the recovery time objective of coming back within seconds or minutes is not appropriate for every business and not necessarily appropriate for every application. So it may well be, for instance, a business can tolerate recovery of their email system to within an hour to recover, or recovery of some other systems like internal websites for maybe expenses or something like that. 24 hours is acceptable in that scenario. So, understanding exactly what each application needs is something we'll talk about in a moment, but obviously is quite key. So then there are two pieces that are really important to understand how we then translate RTO and RPO to the business. So the first one is service level objectives, and this is exactly what are we looking to achieve? What's our aim to achieve within the business in terms of bringing systems back? And I've given you an example there. So service level objective could be that we aim to get back 90% of our production systems within 4 hours. That's an objective. And that objective could be broken down into being smaller and more detailed. So we could say we'll bring back 90% of our production systems in 4 hours. We'll bring back 90% of our development systems in 24 hours, because we know they're less important to the delivery of the business. Then we attach the service level objectives to something called a service level agreement. And the service level agreement is potentially a legal agreement, or at least a binding agreement with the business that would say exactly what happens if we don't meet that requirement. And within the business, they may say that there are penalties attached to that. So, if I was an external provider, that might translate into service credits or an actual money fine for not actually meeting those SLOs. So those are our main terms, and we should keep these terms in mind as we move forward. Okay, so what are our strategies, really, to reduce cost? And pretty much that's why we're having this presentation. We're talking about what opportunities we have to reduce the cost of implementing our disaster recovery strategy. Well, the first one is to think about the idea of varying recovery by process and by application. So we've already said that not every application needs to have the highest level of RTO and RPO, and of course the more expensive, the lower those values are, typically the more expensive they are, and we'll see that in a moment. As a result, we have to look at saying a particular application or a particular system only needs a certain type of recovery, and that we tie that to an RPO. The next stage then is to look at what our technical options are. So within the delivery of DR, we can use lots of different ways to do this. With most of the recovery, we're recovering both systems and data is one of the most important pieces. So from the data perspective, we could look at it and do it in three ways. We could recover the data from using a storage array. So if the array has some sort of replication or backup facility built into it, we could use that. We could move higher up the stack, and we could look at it and say, we'll recover at the hypervisor layer, which obviously gives us a bit more understanding of the application, at least from an operating system perspective. It gives us more of an idea of the data. Or we could step up again and go into the application level. And we could say, let's recover at the application and use the application's own built-in tools or features to do that recovery. And in that sense, we're actually pretty close to understanding how the application works at that point. And we'll see as we discuss these that there are trade-offs within each of those different options. So what about technical options where we haven't really got a DR site? And those first three there are really focused on having some sort of technology we could move to reasonably automatically. Well, there is always the way to fall back to traditional backup and DR, and that's to have disk and tape. The one thing I would say about that, of course, is that if you don't have a target site to go back to, and all you're doing is taking a lot of tapes to a DR site with a provider, you need to have some very, very good processes to recover. Otherwise, you might find that you've got a long and lengthy process ahead of you in that instance. So I've tried to put these all of these recovery strategies onto a diagram to give us an idea of what we think they map out in terms of RTO and RPO. So looking at this in a bit more detail, we start to get into some of the technicalities of how this can be achieved. And this diagram shows a few now. So the first one there is synchronous replication, an array-based technology usually, but not exclusively that. And synchronous replication is very good. It's got low RTO and low RPO because we have to make sure we have a copy of the data at the remote site before we even acknowledge that the host has been able to update the data itself. Asynchronous replication is a little more lengthy in terms of its recovery point because we're not 100% accurate in terms of our updates on the DR side. We could be a few minutes behind, or we could be a few seconds behind. So asynchronous replication is good, but it isn't absolutely as good as synchronous replication. And tied to that is another technology called asynchronous replication with snapshots. And this uses the idea of, rather than sending every update, we only send up snapshots of updates maybe every 15 minutes or so. And it's something you see with hypervisor replication. It's easier to implement. It's less bandwidth, but of course, it doesn't quite give us the same level of RTO, RPO as the other two do. And the final green bullet on this slide talks about log shipping. This is obviously an application process, which is something we could do with, say, Oracle as an example, where we ship the, or MySQL, or those sort of database applications, where we ship the logs to a remote site, and we use the logs to recover the data. It's a bit more involved. We'll talk about that in a moment. And obviously the recovery point and the recovery time can be slightly more lengthened. Now, I've added two other items onto this slide, and I've put them in red because they're not really as strategic as the other options, in that they take a lot longer to implement, to recover from, and potentially there's a lot more involved in actually doing that recovery, and they're not as scalable. So I've just highlighted them in red and said, they're there, they're technologies you could use, and maybe you use those for absolutely less important systems, but you will find that they take longer to recover from. So let's talk about some of these in more detail and why they're different. Why do they cost more, and so on. And we'll go into a bit more detail about that. So let's start with array-based replication. So array-based replication is technology that allows a storage array or storage device, appliance, whatever you want to call it, to replicate data from one to another, from one device to another. And that may be inbuilt technology that the device has, or it may be via a third-party connector like RecoverPoint from EMC. Now, these are really, really good if you have a requirement for synchronous and asynchronous replication, especially synchronous, because every write to the primary system has to be written to the backup system before it's confirmed to the host. So if you have a failure, you absolutely know that you have a copy of your data in the remote site, and it's up to date. It will look like a crash copy, because obviously it looks like the system's just been taken out and not shut down cleanly, but you do have a copy of that data out there. Potentially it's very scalable, because you can fail over a whole array, which could be hundreds of terabytes, or you could fail over a LUN at a time. So you can actually get a lot of data to a remote site and move your operations over very quickly. And that can be achieved very quickly in terms of failover, and it could be seconds or minutes depending on how you implement it. Typically, this technology is agentless, so there's no need to deploy anything on the hypervisor or the client in order to achieve your DR. So in terms of deployment, it's very, very easy and very efficient. However, there are some trade-offs. Probably the most obvious one that people talk about is that it's typically expensive, and it's usually licensed per terabyte of capacity. So for every machine you put down on the floor, you're buying a second box, you're replicating that entire box. Typically, the vendor would recommend that you have it of the same configuration, so you've got double the storage capacity, and you've got to buy a license for the replication software. So it can be quite expensive. As we've touched on already, a failure is treated as a crash copy, so the application and the hypervisor are not aware of the DR failure. All they see is when you bring back the application or the server on the remote site, is that it looked like the server crashed. Now, that typically isn't the problem, although it can be a problem because you may have to go through some sort of recovery process to get that data back. That's certainly the case with applications or databases. One of the major problems with this technology is that it can have a low level of granularity. So if you're looking to replicate and maybe if you had to do, say, a partial DR scenario, maybe you'd lost, say, half of your data center hall because of a power failure and you needed to move some of the servers to a remote site, it could be very difficult or more complex with array-based solutions because you put the same, you can only fail over a single LUN at a time. So every application that's sitting on a LUN would have to be failed over. Effectively, would have the disaster scenario applied to them, and that's not necessarily practical. So you end up having to compromise and put data on more LUNs, or you have to group them together and fail applications over when that's not necessary. And of course, one final thing is this particular technology is either very complex or it's impossible to support into cloud in cloud environments. So as an example, obviously going forward, it would be very nice to be able to fail over applications into the cloud. Array-based replication tends to be proprietary technology, and therefore it's not actually possible or almost impossible to fail over into a cloud provider. There are some exclusions to that. There are some vendors who are putting their hardware, like NetApp, into cloud providers so that you can replicate your application into a cloud provider using their technology sitting in the cloud provider's data center. So there are some exceptions, but of course, again, there's a cost associated with that. So let's talk about hypervisor replication. So what we're doing here is we're moving up the stack slightly. Excuse me. We're moving up the stack slightly. We're going up to the level where we've got a bit more intelligence about understanding what the application is, because we've now got to a point where we're talking about virtual machines. These implementations typically support asynchronous modes, so they don't necessarily replicate instantly. They may be a little bit behind, about maybe a few minutes or a bit longer. However, they are scalable, and they're scalable to many virtual machines in most instances. They are virtual machine aware and application aware because, first of all, obviously you're replicating a virtual machine as an object, which makes a difference. And secondly, because it's a virtual machine, we can deploy agents within the actual guest itself to allow us to understand how to quiesce that application while we're taking snapshots and replicas. So we can actually understand the application, at least be aware of the application in a bit more detail. These solutions have good granularity. We're talking now about a VM. We're not talking about a whole LUN. And when we talked about a LUN previously, a LUN could have, or a volume, two ways to describe it. A LUN could be holding 10 or 15 virtual machines. So getting to the virtual machine level of granularity is a much better way of doing it. And most of these solutions will only work with the change data at that VM, which again is more granular usually than array-based replication solutions. These solutions can support cloud models, so they're pretty good. They're not necessarily easy to do that, but there are solutions out there that will support cloud environments. So there is the possibility of replicating using this method into a cloud environment, which could significantly reduce cost, because you could be in a position where DR is something that happens so infrequently, or you hope, buying a whole set of equipment just for DR can be costly. Being able to replicate into a cloud environment where you can on-demand power up those applications significantly reduces the cost of deploying that technology. Of course, licensing is still required, so there is still a downside to this. Most vendors want to charge for these sort of features. You can have to deploy additional infrastructure to make it work. And that might mean, for instance, additional virtual machines that do the replication for you at the hypervisor level. So those are good solutions too, and obviously just some negatives there. So let's talk about application replication. So at this point, we're talking about the application itself doing the replication. So we're shipping logs, or the application is clustered or is built in such a way that allows us to distribute the data naturally. As we move forward with the redevelopment and the rewriting of a lot of applications, this is probably likely to be one of the most common ways to do DR. I'll give you a good example of the technology that could do this at a storage level, and that's object-based stores. So object stores are designed to disperse data geographically over multiple data centers, multiple sites, and if any one fails, the data can be recovered from any of the other sites. We're not wholly dependent on having that data back or going through some sort of DR process to get the information back. And that's more of an application-based approach than it is purely just hardware recovery. And that's probably where we're heading towards with a lot of applications. Now, obviously, these solutions will be VM aware. They just work within a VM, so there's no real issue there. And by definition, they're application aware, of course. These solutions can work really well with cloud deployments because you can have some of the environment sitting in the cloud and some outside, or you could distribute it across cloud providers. So potentially these could work really well with the cloud, and as a result be therefore a lot lower in cost. So what are the downsides? Well, potentially from a deployment process, these solutions might not be scalable. If you had hundreds of applications of a similar nature, the recovery process of each one could actually be quite lengthy if you have to go and check each one independently. So there could be a bit of an issue in terms of the management overhead of going through that DR process. Potentially you still require licensing depending on what the technology is, and you may have to pay for that. And depending on how an application is being constructed, if it's a legacy style application, it may well be that there are many sub-applications and databases and so on, all of which need to be recovered independently. And that could make the overall recovery process quite complex. So we talked a little bit there within the discussion about whether we should do LUN or hypervisor replication. And this is quite an important one because it has quite a bearing on how you should lay your data out, how you should construct your VM environments, and possibly how you should use the storage that underlies both of those. The two choices are either we build a LUN or a volume, depending on how you want to describe it, LUN or a volume. We put our virtual machines on there, and that LUN is then replicated by the array. The array typically only sees the LUN as its smallest entity in terms of replication. It can't replicate smaller than that. It has to fail over an entire LUN to a remote site or more than one LUN. The LUN is the smallest thing. And as we know, within virtual environments, the larger the LUN, the better, because we're limited in terms of the number of LUNs we can put onto a system. So we tend to deploy big LUNs as data stores and have many virtual machines in them. And the negative is, of course, they would all have to be failed over if we had some sort of issue with the primary site or with some of the equipment in that site. Hypervisor replication gives us the ability to move down a level, and we can look at the idea of using replication at the VM level, which is a much more logical object for dealing with virtual machines. Pretty much everything we want to do is related to a virtual machine, so failing over a virtual machine and failing that virtual machine back is obviously the ideal solution. The trade-off, of course, is that LUN-level replication can be very efficient because we can use things like features like deduplication to get the data to the remote site. That isn't sent over the WAN, and there is a trade-off between using both of those technologies. And it really depends on what you're looking to achieve. So if you really want to go down to the LUN level, and the LUN level is sufficient, then array-based replication is great. If you want to get down to the VM, then you should really be looking at replicating within the hypervisor. One final comment to say on this, by the way, of course, is that we're starting to see new technologies come out that are looking to fix this problem. A good example, which is imminent, is vVols from VMware and from storage vendors, and that feature will allow us to store data on a storage array, but actually work with the objects on that array at the VM level. So we won't be tied to the LUN. We'll be able to treat the VM as an object on a storage array, and the storage array will be able to manage that object for us. And that's a big step forward because it takes away all of this discussion about whether we should have a LUN or a hypervisor as our point of failover. And it means, as a side effect, which is really good, but not part of our discussion today, it means we can apply quality of service to that object too. And that, again, is a significant benefit. So, how do we translate some of the things we've talked about into best practices for building a DR strategy, and how do we save some costs out of this? Well, the first thing is to start looking at having what I would call a tiered DR plan or a service catalog DR plan. And that would be a DR plan that has multiple levels of recovery and different techniques, each with a different RTO and RPO. And the reason for that is clearly not every application needs to be brought back instantly from in the event of an outage. As we've already discussed, some systems like development systems might be able to sustain a considerable outage. And there may be other systems that generate their data from elsewhere and so, of course, can just be recovered once the primary systems are brought back. So really, you need to look at it and say, I need a number of different recovery methods, each of which will have a different cost, one will be cheaper than the other, and the closer we get to RTO, RPO 0, the more expensive they will become. But we build a number of different techniques that allow us to do that recovery, and we work with the business to prioritize each of the applications that we have against this recovery requirements. And that's the key piece. So we have to talk to the business, and we have to understand their needs, and we have to understand it from both the recovery time perspective and their prioritization, because clearly they may have some applications they need to bring back first before they bring back others. From an infrastructure perspective, the same thing applies. So there may well be some infrastructure pieces we must bring back in the event of a disaster recovery process. So we may have to bring things like Active Directory domains back if they're not already duplicated. We may have to bring back things like DNS and so on. Network may need to be switched, and all of those sort of infrastructure pieces that are needed before we can even do the recovery process, before we can even log in and do the recovery process. One final point, of course, is that wherever possible, we should be looking at using automated technologies to handle the recovery process. Now, if we can handle a recovery process automatically and have systems fail over, that's one level of recovery. Another would be to have tools that allow us to actually recover systems remotely at the remote site and to validate the data at the remote site as we do the recovery process. So wherever possible, if we can automate things, we can certainly scale higher. So let's do a quick roundup of vendors as we get towards the end of the presentation. And from a hypervisor perspective, there are two main commercial vendors out there. There is VMware and there's Microsoft. From VMware's perspective, they offer two products. They offer vSphere SRM, which is a tool which helps to automate the management and recovery of virtual machines. And that can either use array-based replication or you can use hypervisor replication. The hypervisor replication tool being called vSphere Replication, which is actually doing replications of virtual machines across the network. From Microsoft's perspective, the tools are Hyper-V Replica. This is virtual machine replication within Hyper-V, and that can be driven either through the GUI or PowerShells, and it integrates with System Center for the automation of those processes. And what we're looking to see in the next version of Microsoft's Hyper-V and Windows Server platform will be Storage Replica, and that may provide us some additional features to allow us to do this kind of replication more effectively. From a third-party vendor perspective, we have a number of tools. If we're looking to do VM backups, we have technology from Zerto, which can do backup and recovery for enterprises. That's the product name. This uses a VM to effectively feed the data to a remote site, so you can do the recovery remotely, and gives you something that looks like a crash copy of your application or your virtual machine. There's also Veeam's backup and replication product, which covers both the backup requirements and obviously the ability to replicate data remotely, currently in version 7, and I believe version 8 is imminent. And then from a data replication perspective, StarWind, obviously the we should talk about them. They have a product called Virtual SAN, and Virtual SAN effectively gives you the ability to create LUNs that sit on the primary site, and you can both synchronously and asynchronously replicate those LUNs to a remote site for disaster recovery purposes. The benefit of using the StarWind system, of course, is that it's agnostic to the hardware. So you could build out a system at one site and have it at another, and the hardware itself doesn't have to be identical, doesn't have to be identically configured, and so on. So you could choose to put in, at the remote site, only enough capacity to handle the recovery of the systems that were important to you. So it would allow you to cut costs and be very specific about what you wanted to replicate. And finally, we have a product called Double Take Availability from Vision Solutions, which again similarly allows you to replicate data from one virtual machine to another, so you can manage failover of those virtual machines. Let's just finish up by looking at one last slide. And that's all about choosing the right product. So, we've talked a lot about recovery point and recovery time objective. And ultimately, cost is all driven by how quickly we need to get our systems back up and running. And if we're really looking to get things back absolutely quickly, with the fastest minimum outage time and with no outage of data, then we would have to look at technologies like VMware's fault tolerance, and Virtual SAN is another option we could use there, and obviously StarWind's Virtual SAN would fit into that category too. The alternative is, of course, we could look at pure replication at the array level, and we would be able to still look at products like StarWind. We could use array-based replication, VMware replication, and Hyper-V replica. So that still gives us that recovery point very, very quick. Now, assuming our recovery point, we can be a bit behind in our data, but we want the data back fairly quickly, then technology like snapshots would be great for that. So Veeam's backup and replication would be a good example there. And finally, if time is less of an issue for recovery, and we're not too worried about how far back in the past we need to go, we could look at more traditional solutions. So we could look at things like net backup and backup exec and tape and disk backup solutions that might actually give us the ability we need without actually incurring as much cost. And effectively here, we're doing exactly what we've talked about all the way through the presentation. We're stacking the different layers of recovery techniques against the cost of implementing them. So with that, that was the final slide, and I think we're moving into Q&A. Matt, did you want to curate that part of the presentation?
Yeah, great. Thanks, Chris. So I do want to remind everyone, if you have a question, to get it into that Q&A box there to the left of your screen, and we'll get it over to Chris here live. But first up, we have one from Roy, and he's basically asking, what is your opinion on the Acronis backup software?
Okay, yeah, that's a good question. So Acronis have got a number of different products out there. So obviously they're looking at backup in lots of different ways. So they'll do backup to the cloud. They can do straightforward VM backup and so on. I think it's a good product, and I've written about this as a good product in the past. It'll fit the VMware environment, and it'll work with a lot of physical platforms as well. So it works with Windows, Linux, and PCs. I think the VMware side of the product is pretty good, but again, it's one of these things where I would take an opportunity to actually look at the software, maybe get the vendor to take you through an evaluation and try and match it to what your requirements would be. So, for instance, actually look at it and say, what am I trying to recover? Is my environment all VMware? Do I need to recover anything outside of that? Do I need to do physical server recovery and so on? So I think it's a good product. I would work with the vendor to try and tie it to exactly what your requirements were.
Great. And this next one from Norman. What technique strategy is used to establish the RPO RTO? And then also he's asking if there's a book that you would recommend on that subject.
So that's a great question. So the key piece there is, of course, it's all about what the business application requirements are. So that can be tricky, because obviously if you go to the business owner, I think you'll probably find that the business owner will say, oh yes, I need my application to be back instantly. It needs to be running 100% of the time. Well, when you present the business owner with some idea of what that might cost him, fairly quickly people start backing off and saying, okay, can I do it cheaper? Is there another way to do it? And really it's a conversation with the business owner to understand why they need their application to be back so quickly. If they're key to the business, if they're running people's payroll and that has to be done every day, there's a fairly good chance that that's important to get back pretty quickly. So I'm not sure. I'd have to go and take that question offline about whether there's a book or something that I could recommend on that. There are lots of good books out there. But what I would say is you need to sit down with your business owners and understand their requirements and explain to them what the techniques you could use and the associated cost, and try and work out to them what's important. Is it cost that's important to them, or is it the application being back? Because typically when you talk cost, people very quickly change their opinion.
Great. And we have another question here from Roy from Iceland. And he's basically saying, seems like the future is cloud services, but what security concerns are associated with moving DR to the cloud?
Okay, another great question. So clearly we can look at it on a number of different levels. So if we're putting our data into the cloud, then obviously we want to be 100% happy that we know that data is protected, and protected from people who shouldn't be looking at it. So clearly as you're putting that data into the cloud, you would want to encrypt it in flight. So as the data is being transmitted across the wire, you need to encrypt it. And when it arrives at the target site, you would be wanting to encrypt it there too at rest. So when it's on disk, when it's actually sitting on the systems, you want to encrypt it. And that means you need to own the encryption keys. So you don't want to be encrypting data and then suddenly finding the cloud provider also has the keys, because the keys could be at risk. Somebody could compromise the encryption keys, and you're no better off. So if you're going to put data into the cloud from a security perspective, I would suggest the major two things to look at are making sure the data is encrypted while you write it there, and then when it lands there, you need to make sure it's encrypted on disk, and you need to own those encryption keys.
Great. And this next one from Ari. How would one determine what type of speed of WAN is needed for offsite replication DR? Okay,
yep, fair question. The key piece there is to understanding the rate of change of your data. So let's think. So I'm going to give you an example. So if you have an application which has a high number of write operations, so you're writing to disk continuously, to get that application off-site, you'll need to be able to write at the same level of performance if you want to replicate every single transaction, every single thing you've done. That can be very expensive, and obviously that's something you have to consider when you're looking at the cost of all the different solutions. You could measure that by measuring the primary site and looking at, running some system counters that are looking at the activity there, or maybe if it's on a traditional storage array, you could look at that array and look at the array's metrics to see what the write I/O activity is. That's one way of doing it. Another one could be to look at taking snapshots and then replicate the snapshots. And the reason for doing that is because taking a snapshot effectively consolidates writes all up together, and then you replicate the snapshot itself. If you take snapshots, you get an idea of the rate of change of the data, and you might say take a snapshot every 10 minutes or 15 minutes. You could look at the size of the snapshot and that will give you an idea of how long it would take to get that data to a remote site. Imagine the snapshots are a megabyte, and it's a megabyte within 15 minutes. You can work out the bandwidth you need. But imagine you were taking, you were doing a snapshot and it was a gigabyte each time. A gigabyte within 15 minutes would obviously need a much bigger network. But that's probably, those are sort of some of the methods you would go about trying to estimate how much bandwidth you'd need. It's always really difficult because obviously as we step back down to the array level, the arrays can be very efficient with their replication. So some of them will dedupe at primary and secondary and only send up across tracks the deduplicated data. So there are some vendors who can make that process really efficient if you need it to.
Great. And I do want to throw Chris's contact info up there one more time. So if you'd like to reach out to him offline, he's got his Twitter handle and websites there to check out. So it looks like this will be our last question from Stuart. But if you do have a question, get it into that window, and if we don't have time to address it live, we will be able to follow up with you. So this one from Stuart. How is Altero, I don't know if I'm saying that right, how is Altero as a VM backup to disk and cloud?
Okay, that's not a product I'm 100% familiar with, but from off the top of my head, I believe it's only a Hyper-V product. I'd have to go away and double check that. So I might suggest we take that one offline because I'd have to just go away and be absolutely certain. But I think it's only a Hyper-V supported tool, so that's not going to help you in a VMware environment as much. But I can take that one offline certainly and come back to Stuart on that one separately.
Okay, great. Yeah, Stuart, so keep an eye out. We'll follow up with you on that. But yeah, that's basically all the questions that we have today. So I do want to thank Chris for the great presentation and great Q&A session there. Chris, is there anything that you'd like to say to close us out?
No, just thank you for your time. If anybody's got any questions, then absolutely feel free to drop me questions about specific products or concepts or anything like that. I do get a lot of briefings with vendors, so there are certainly a lot of the products that I tend to have a bit of in-depth about, and it may be something that I can help out with, and I'm certainly happy to do that.
Great. Well, thanks again, Chris. So I do want to remind everyone as we close out today that if you had to step out or missed any part of today's presentation or even just want to go back and rewatch it, you will be receiving an email in a couple days with a link to view that on demand. So again, Chris, great presentation. And I just want to give a special thanks to StarWind for sponsoring today's event. And also, I want to thank each and every one of you for taking some time out of your day and tuning in. We hope to see you back again very soon on another Spiceworks Partner webinar. But until then, stay spicy.